And it doesn't just have to be an x plus a y. Okay? So if you want to expand completely and simplify, the first thing we would look at is the 4, and that tells us there's 5 terms. So going to our Pascal's triangle, we would have to go to row 5, the 1, 4, 6, 4, 1, till we get 5 coefficients. And when I go to write this out, I actually start 1, 4, 6, 4. Try to space it out. I know that those are going to be my coefficients, so I'll write them in blue to match up. Then, my first term is a 3b. My last term is a minus 1. We're going to start with 4 of the 3b's. Then 3 of them, then 2 of them, then 1 of them, and finally none in the end. My second term is a minus 1. So we start with none of them, then we have 1 of them, then 2 of them, then 3 of them, and finally 4 of them. In any term that you look at with the exponent being 4, the exponents add up, right? Because 1 of these and 3 of these, that makes 4. 2 and 2, that makes 4. 3 and 1 of these, that makes 4. So this is just the setup, how to use Pascal's triangle and the pattern to set this up. Now to simplify, let's just simplify all the brackets by themselves. Well, times by 1 won't matter. 3 to the 4, that's 81. B to the 4 plus 4. If I do this exponent, 3 cubed is 27, b cubed, and then a minus 1, plus 6, 9b squared, and negative 1 squared will be positive 1, plus, I guess 4 times 3, I could write that as 12b, negative 1 cubed will be negative 1, and negative 1 to the 4 will be positive 1 times 1 will be 1. And now, just finish, if I have any other simplifications here, I can do 4 times 7, that will be, under negative, this will be negative now, 108b cubed. 6 times 9 is 54, b squared, minus 12b plus 1. And the idea is this would be quicker than our old methods. Our old method is that you would write 3b minus 1, 3b minus 1, 3b minus 1, 3b minus 1. You'd multiply these two together and get 9b squared minus 6b plus 1. And these two together and get 9b squared minus 6b plus 1. And then we would have a lot of arrows to do, right? You can write all those out and combine like terms and put it together. The idea is that Pascal's triangle is not a lot faster, but a little bit faster. And it will be a lot faster if the exponent was bigger than 4. Can you imagine if that exponent was a 10? Oh. Doing it the old way, you just have so many things to multiply in the end, you get bigger and bigger and bigger. So Pascal's triangle allows us to do it quicker. Again, how do we use it? We look at the exponent that tells us how many terms. There's always one more term than the exponent. That tells us which row to use in Pascal's triangle. Since we had 5 terms, I needed the row with 5 things. I wrote out the 1, the 4, the 6, the 4, and the 1. Whatever your first one is, your first term in your binomial, you start off with 4 of those and go down by 1 each time. So I started off 3b 4 times, then 3b 3 times, all the way down to 0. And whatever your second term is, which if there's a negative, the negative stays with the term. Start off with 0, then 1, then 2, then 3, then 4. If the exponent was an 8, you'd start off with 8 of them, then 7, then 6, then 5, then 4, then 3, then 2, then 1. And so on. Now, sometimes they'll ask you to explain something completely, but more often they'll just say, could you just find the third one? What are ways that we could work with this idea to find the third one quickly? And that'll be our next concept in our next video.